I'm also coming from limited understanding. So thanks for attending. I'm a senior research associate at War Resources Institute, and I'm also a student at Georgia Tech. So I guess this will probably fit somewhere in the like hobbyist part of using OSM. Let's see. So we have internally, we have questions that like one of the researcher asked, essentially is how many highway roads are, like what is the length of highways in any cities in United States? So that was a question that one of the researcher wanted to ask Adam Davison's. And then would you be able to do that in any geography just by simple query? So the aim is like to do comparison. So we have a lot of information about the demand side, which is like the ridership information. I'm coming from transportation background. Can we do some bookkeeping, so supply of transportation, and then we try to see if there are already existing data, and then so we want to use open sources tools as much as we can. So that's where we are. And then that's how we landed in this OSM. I'm still very new to OSM. So we try to look at different available data sets across the world because we are global organizations, and this seems to be one, even though the data quality varies in different places, that we might be able to use a lot of data initially. So I'm coming from the user perspective, and then not knowing much about OpenStreetMap yet. So I'm here to learn too. This is from Janning talks from YouTube. I don't think that's from the state of the map, but he presented that. I just screenshot it. So as you all know, the data quality varies in terms of where, depending on the mappers, and this is according to one of the paper that he presented in one of the events. So the journey, as I said, it's going to be about journey. We started with like earlier prototype in Google Colab because the other person is an urban planner. He has a questions, and I know a little bit about how to play around with this. So we started with Google Colab allows you to like collaborate and then give him things that he want to do in an easy way that do not require a lot of coding. We started looking more of a OSMnx, which Professor Jeff Bowen has done a lot of open source tools in order to clean up the existing OpenStreetMap data and connecting to the network. So some of you might be familiar with all of these. This is some of the things that you can do. Can anybody guess where this is? I hope people are not falling asleep. It says Uganda. It's in Kampala. So that's this. I guess this one takes about 20 minutes, 30 minutes on my very small laptops, and then there's a line of code up there. And then these are also in East Africa. Anybody? Any guess? One of them is Rwanda, or Kigali. I think that's what this. And then this one is Addis Ababa, Ethiopia. So those are some of the things that you can do with the OSMnx, which is thanks Professor Jeff Bowen for that. I think the issue. Then we do other things like trying to build on this and then see what kind of data we can extract from OpenStreetMap. And this is like a classical comparison at this point, at least in urban planning, where you're comparing Houston and Vienna, and then see like the same radius. So you're comparing the two radius, and then see what are the routes of highways in that particular radius compared to Vienna. So Houston, the way because the cities are planned, you have like a lot of more highways compared to Vienna, like 2.72 meters of a highway per person, as opposed to Vienna. If you just compare, this could be a communication to show urban planner how you plan your cities matters. And this affect, so we started doing that, and there are more things that we play around, try to see different cities. Again, selecting radius of the same, I think it's 50 kilometer, and Adam did that, and try to compare for all the different city center where, in terms of like population density, which area might have a more highway or all sorts of different types of roads. And it's interesting to see this pattern, which is also a classical curve in a lot of urban planning literature. And then the next step that we were trying to do was we wanted to make it faster. So OSMnx was good and then probably very accurate because they essentially clean up all these networks and rebuilt the entire networks. So in order to make it faster, last year I was here in Tucson, and then I heard the talk from Janin, who talk about this daylight. So it's essentially they clean up the OpenStreetMap data set and then put it in the AWS Athena, so you can query it much faster than if you use AWS. It takes from 30 minutes to, I guess, a few seconds of query if you just want the basic summaries of different streets. This is the final pipeline for this thing that I'm going to show you. So at the back end, we have a little bit of OSMnx to look at the query boundary, and then it's query information from S3 backend that's put in the daylight. In the front end, we just use Streamlit. The codes are in that GitHub list. Most of them are free, I guess. The only part that's a bit you pay is this the query data, a few cents by the amount of data that you scan. So this is how we use the tag in OpenStreetMap. So we define into, this could be refined, but we define into 3 different category. Auto dominant street, the street, if you have all these different tags, then we will consider that's auto dominant streets. And then livable streets, if you have protected cycling infrastructure, busway, etc., then we will consider as a livable feature. And then cycle roads, any designated cycle paths. So this is the rough category that can be further refined. So imagine like a street, and then all of those can coexist together. You can have 5, which you have auto dominance. So this is the categorization we did, which can be rather refined. And then are we? Sorry. So wait. So if you go to this link, this is where the tool is, which is a prototype. You can play around with that, and I'm gonna quickly show some of the results. We're comparing Washington D.C., Amsterdam, and Bogata, or you can do it at the like a borough level in New York City, or comparing the entire Germany with California, maybe about the same size maybe. So that's some of the things you can do. Again, this is a beta version. It's a very prototype. We need to compare the results from OSMnx, which to me, it's the gold standards in terms of the accuracy, and with daylight and other manual download from OSM. So you can do what I'm going to show, the same thing in GIS. Maybe it would take longer if you have to, like, it's the app is not very good on the phone. And then we need to do a little bit more testings and to make sure that nobody is secure. It's like the security is fine and more caching. So let me go to the link. Hi. Yes. Okay, where is the link? Here. So it's built on Streamlit. The URL, I haven't even changed the URL. So the other URL, bit.ly.street supply.tc22. So this is the web app. This is live. You can start. I don't know. Give me some cities. Right now we have Washington D.C. We can do Richmond, I don't think you need USA. So this is just to make sure you are looking at the correct current boundary because this is pulling directly from OSM. This is what OSM understand as Washington DC or Richmond, and you can do Bogata, Columbia. So, so yeah, I mean then you can move around a little bit. Then there's some WKT that if you want to see the polygon, but this is just to check you're having the right boundary, and this is the part where you can do the counting of all the streets. This is a little bit of a funky interface because I don't want people to be using the computational resources too much. So you can keep anything as long as you don't use dash. So right now, what it's doing is right now, like it's scanning the daylight database that's stored in the AWS to calculate the different street lengths. So it's yeah. So if you can give more cities about one per line, and it should be fine. But it's the first one always takes some time, and then if you do again and again, it should be faster. But as I said before, this is the prototype. So yeah. Any questions on this is slowly? Questions? Oh, cool. Hi. Not? Yeah, it's a Python library, and the code, because I'm using the Streamlit, so all the codes need to be open. So I think the codes are all in GitHub. I think the only part that's not free is the AWS part, where we want to run it faster to make the computation faster. So again, this is the definition what I just presented, how we define it, and you can see the results. It took about 50 seconds to do all this scanning, the OSM data set that scan, and you can download the raw data. In Washington, DC, the total street length, it's about this kilometer, and then what we consider auto-dominant is 590. And they might be overlapping too, because if you remember that circle, in the same space, you can have a circle rows, and then along with the auto-dominant row along the same time. So that's according to OSM one version. This is the percentage of auto-dominant streets, which is about 14%. Richmond has a little bit higher because what we consider the livable, which is Zygo, interesting. Livable is and then Bogata. Bogata has more bike lane. So, and then this is how we use the tech. Again, this is yeah, I'm done.